Welcome to this explainer. Look, if you're building software today, the tools you use are fundamentally shaping the software you create. Today, we're tracing a developer's exact path, starting from a simple decision on where to host code, all the way up to scaling a global enterprise architecture and leveraging bleeding-edge AI. We're going to see exactly how that evolution happens. Here is our quick agenda for today. We'll start with number 1, GitHub versus GitLab in 2026. Then number 2, the anatomy of a DevOps platform. After that, number 3, scaling globally with Geo. And finally, number 4, the AI future with GitLab 19.2. All right, diving right into section 1, GitHub versus GitLab in 2026.
Before you write a single line of code, you absolutely have to answer this critical question. Picking the wrong platform, well, that usually means you'll end up stitching together a bunch of extra third-party tools later on. That drains your budget and just completely overcomplicates your pipelines. Both platforms are incredibly powerful, and yes, both use Git under the hood, but they serve two very different core philosophies.
And it really all boils down to that philosophy. GitHub is essentially the undisputed home of open source. If you're looking to build a massive public portfolio, it is unparalleled. But GitLab? GitLab was engineered to bring your entire software development lifecycle, planning, coding, testing, deploying, and monitoring, into just one single unified application. Breaking down the specific features, you can see GitLab really taking the crown for built-in CI/CD pipelines, enterprise self-hosting, and deep security scanning, hitting top marks across those categories. GitHub still dominates open-source discovery with top marks there, and its integration ecosystem is massive. But if your company needs to lock things down and run everything on its own servers for strict compliance or privacy, GitLab's self-hosted options are just substantially more flexible. There's a great quote from the dev community that really hits the nail on the head. Choose GitLab if you need a full DevOps pipeline out of the box. Choose GitHub if you want to build a visible portfolio. Ultimately, it comes down to your primary goal. Are you prioritizing public visibility, or are you after deeply integrated enterprise controls? There's no wrong answer here, just the answer that fits your specific project. Moving right along to section 2, anatomy of a DevOps platform. Let's peek under the hood. It's honestly wild to look back at how this evolved. What started way back in 2011 as a simple Ruby on Rails side project by Dmytro Zaborizets has completely transformed. By 2026, it evolved into a massive AI-integrated enterprise powerhouse, completely supporting advanced agentic capabilities in the recent 19.2 release. For the system architects tuning in, this is what that anatomy actually looks like. Rather than being just one giant monolithic block, the platform relies on a symphony of interconnected services. You've got Puma and Nginx handling the web traffic, Postgres storing your relational data, Redis jumping in for caching and queues, Sidekick crunching those heavy background jobs, and Giddily managing the actual Git remote procedure calls. And all of these pieces are highly interconnected, relying heavily on Unix sockets to keep internal communication lightning fast. All right. Section 3, scaling globally with Geo. Let's talk about what happens when your project explodes in growth. So what do you do when your lone developer project turns into a highly demanding, globally distributed team? This is where GitLab Geo steps in. Now, I want to be super clear here. Geo is not an out-of-the-box, active high-availability solution. It operates on an eventually consistent synchronization model. It's strictly an active-passive, warm standby tool, and it's designed specifically for disaster recovery and for crushing the latency experienced by remote teams. Think about fetching a huge repository from a server halfway across the globe. Without Geo, you could be waiting agonizing minutes. But this active-passive workflow slashes that wait time to seconds. Say a developer in London pulls code. They read it instantly from a local secondary cache. But if they push a commit, that write request is transparently proxied right back to the primary site, maybe sitting in New York. The database updates are then streamed back to the secondary site via PostgreSQL replication. It's incredibly seamless.
In the real world, this solves two massive enterprise headaches at the exact same time. First, you get a warm standby that's ready to go during a data center outage, giving you a super low recovery time objective. Second, you completely stop your remote developers and your heavily utilized CI/CD runners from bottlenecking on slow cross-region connections. You are effectively offloading all that heavy read traffic away from your primary instance.
But here's the catch, and it's a big one.
Deploying this architecture requires absolutely strict environmental alignment. You must maintain exact parity across your deployments. The major, minor, and patch versions of GitLab have to match perfectly between your primary and secondary sites. You also need identical PostgreSQL versions, and you must have robust private network connections, like internal VPC peering, because exposing database replication ports to the open internet is just a massive security risk. Plus, you need to budget for at least 40 gigs of extra disk space per site just for the tracking databases.
Finally, Section 4, the AI future with GitLab 19.2. Let's check out the bleeding edge. This is where things get truly futuristic. The new GitLab Duo CLI brings the agent platform right to where developers actually live, the terminal. This isn't just some disconnected AI chatbot sitting in a browser tab. This CLI has deep, localized context about your specific projects, your pipelines, and your custom agent configurations defined in your agents.md files. Because it uses Model Context Protocol connections, it knows exactly what you're working on, and it can run interactively with you or totally headless as part of your automated CI/CD pipelines. Let's trace exactly how this context works in practice, because this is a massive leap forward for dependency scanning auto-remediation. Imagine a vulnerability gets flagged. The system doesn't just ping you on Slack, it automatically opens a merge request to bump the dependency version. But wait, what if that version bump introduces a breaking change that fails your pipeline? That's when the agentic breaking change resolution kicks in. The AI actively reads the pipeline errors, checks the dependencies changelog, writes the code to fix the breaking changes, and commits those fixes directly to the MR until the pipeline is completely green. It's literally fixing your code for you. And what about those dormant repositories you haven't touched in months? They aren't sitting ducks anymore. By using scheduled pipeline execution policies, your security team can define a schedule once in a centralized policy project and force it across every project in scope. This means you can run those AI remediation scans on a strict daily, weekly, or monthly cadence without a single developer needing to push a commit. Total automated coverage. Which brings us to a massive question to end this explainer. We started this journey by simply picking a place to host our code, but by the end, we've arrived at an architecture where the very tools we use are actively building and repairing the software themselves. If AI is autonomously handling vulnerabilities and fixing breaking changes, your day-to-day focus as a developer is about to shift dramatically toward higher-level architecture and orchestration. So how will your role evolve in the pipelines of tomorrow? Thanks for joining me on this deep dive, and keep building.